This is Amr Khalid, and today I'm going to explain the Russian multiplication algorithm in details. Welcome to an exploration of the Russian multiplication algorithm, a fascinating strategy used to multiply two numbers through a series of halving and doubling. I want you to imagine two friends devising a plan. Instead of straightforward multiplication, they decide to simplify the process by using doubling and halving, breaking down the problems into smaller steps. Coming to the steps of the algorithm to solve this problem. As you can see, we have these two numbers that we want to multiply. The first step I want you to do is you bring the first number and you divide it by 2. And the second number, I want you to double it or multiply it by 2 and get the result, and keep performing the step until you find an odd number on the left, or a number that has a remainder after dividing it over 2. What I want you to do is eliminate this remainder from the number and leave the number as it is. And then keep performing the step until we're left with 1. Now, the second step. You should look at every odd number that you have on the left side. Then take the corresponding number to it on the right side. Collect them and calculate their sum. And finally, we are left with the product of these two double-digit numbers that we have, using such an easy method. Coming to the code implementation. Now again, I want you to imagine two friends devising a plan. Instead of straightforward multiplication, they decide to simplify the process by using doubling and halving, breaking down the problem size into smaller steps. So in the first step, I will need you to have a variable that carries the result and then loop on the first number until it becomes 1. In this while loop, check if the n modulus 2 is 1. If so, add the m to the result, and if not, jump over this step and perform these two steps. N equals the floor of n over 2, and m equals 2 multiplied by m. Iterate again until n becomes 1, and eventually return p plus m. And this will be the product of the two numbers that you will need to multiply. Right. Now let's dive into the recursive type of this algorithm. Let's consider calling the function with the parameters n and m. For instance, when we put 13 and 7, the algorithm will start by checking if n is odd or even. In this case, 13 is odd. So it dives into the else condition and calculates calling the function, carrying 13 minus 1 all over 2, and 2 multiplied by 7 plus 7. This process continues until it reaches the base case, and voila. After the recursive journey, the function called carrying 13 and 7 yields the result, which is 91. By looking at the previous code, it tells us that this algorithm falls with the decrease by a constant factor type of algorithms, which happens when we decrease the larger number by half in each iteration, effectively reducing the problem by a constant factor. Now the analysis. I will use recurrency with this analysis. I'm analyzing the recursive code. We will have t of n equals t of n over 2 plus 1, all plus 1. So this recursive relation yields a logarithmic time complexity of O log n, as the number of recursive calls reduces n by half each iteration until reaching the base case. This pattern converges at O log n iterations due to n reaching 1 when k equals to log n. Thank you.